So, very good morning and welcome back again. So, today we continue the discussion on the topic, broad topic, fundamentals of data analysis. And we are here the area again, and that is exploring data analytics. And then we're going to talk about calculating and interpreting the common descriptive statistics. So, this is the subtopics today we are going to discuss today. So, let us get into the further discussions on the topics. Right. So now we already spoke in the previous class regarding what is meant by mean. Now we talk about what is meant by population mean, and we already spoke about what is group data, what is ungrouped data, and we have a basic understanding of grouped and ungrouped data, and we also have a basic understanding of what is meant by mean, and also what we mean by sample as well as population. Now let us understand what is meant by the population mean. Now when we talk about population mean, then we take all the values in the population. Okay, and then that is in the numerator, and the denominator is the total number of population values, right? So this is actually the population mean. Now mu represents the population mean. It is a Greek letter represent, and it is spelled as mu. And n is the number of the values, the number of data points in the population. And x represents the particular value. And sigma is actually also a Greek letter, which is also called sigma, and indicates the operation of adding. And sigma is actually the sum of the x values in the population. And when you do this, we get a population mean. Okay, so this is what it is. And let us understand with the sum. Now, there are 12 automobile companies in the United States, and you can see that a number of patents granted by the United States government, each of them in a recent year is given. There are various numerical values. Now, this information is a sample or a population. Now, there are 12 companies in the United States, and all the 12 companies are listed here. So, definitely, this is not a sample, this is a population. And the arithmetic mean number of patents granted is add all these values 511, 385 up to the 13th value. And since there are 12 companies, your population mean is 195. So, this is a very simple calculation of the population mean. Now, what does sample mean? So, we basically understood already, we have very clear understanding of what you mean by population and what is the sample mean. And for ungrouped data, so both we now talking about population mean and sample mean with respect to ungrouped data. Now, ungrouped data, the sample mean is sum of all the sample values, which is the numerator, and divided by the number of sample values in the denominator. X bar is written as x bar, and n is the number of values in the sample. So this is actually the sample mean. And let us understand this sum. Suncom is actually studying the number of minutes used by monthly by clients in a particular cell phone rate plan. A random sample of 12 clients show the following number of minutes used last month. So client wise, what is the talk time recorded by the clients is actually recorded. And what is the arithmetic mean number of minutes used is I add all the values in the numerator and divided by denominator is 97. And sample mean is fundamentally different from population mean because for every population we can have different sample means values. But and they can vary from sample to sample within a population. But population mean is one single value. It is only calculated one time, and it is actually constant for a given population. So that is why the sample mean and population mean are fundamentally different. Now, properties of the mean. Mean measures stability. Okay, the mean is the most stable value among the measures of central tendency because every value here is contributing to the value of the mean because it's stable. All the values are incorporated in the mean. And sum of each score's distance from the mean is 0. And that is what it talks about. The deviation when you add all the things, it is 0. And it is easily affected by the extreme scores because when you have the extreme scores, the mean definitely tends to vary. That is also called outliers. And it can be applied to interval level of measurement. Mean is applied to interval level of measurement. And mean may not be or may not be an actual score in the distribution. And it is very, very simple and easy to compute. And mean of the group data, how do we calculate this? We need to understand these three things. Group data is actually data or scores which is arranged in a frequency distribution. Frequency distribution is arrangement of scores according to the category of classes, including the frequency. Frequency is the number of observations falling in a category. So based on this, the group data is done. And this is the formula for calculating mean for a particular group data, midpoint method, where x bar is equal to mean value represented. Xm is the midpoint of each class or category. Xm. And that is the value itself. And F is the frequency in each class or category. And sigma is the summation of the product of both. So you multiply the frequency as well as the midpoint and add all this, then we get the numerator summation. And solving is very simple. Find the midpoint for each and every class interval, lower limit plus upper limit by 2, and then multiply that by the frequency and we get f into xn. Find the sum of the results and then solve using the formula. We get a simple sum here where we have this class interval 10 to 14 up to 54. Then we have the frequency. Then we find out the midpoint of each and class interval by lower limit plus upper limit by 2. Then multiply, we get summation is 260. A summation of 1345 divided by 40 is the number of data points. So 33.63 is the mean of this particular group data class interval. So thank you very much for patiently listening. Look forward to meeting in the next class. Thank you very much.